Usually formed when a massive enough star collapses at the end of its life, creating an object so strong that past a certain point, the event horizon, nothing can escape, not even light. Inside, there's an infinitely dense singularity, a final destination for all the matter a black hole consumes, and a place where the normal laws of physics no longer apply. For decades, black holes were theorized but not proven. But now we know they exist. Now then, the theories have moved on. And based on all we know of black holes, there's a new cosmic conundrum in town: white holes. We've yet to actually observe a white hole in space, but scientists have a good idea of what one would be like. First, despite their name, they might not actually be white to look at, and could even appear visually identical to black holes. The crucial difference is in how they function. A white hole is the theoretical opposite of a black hole. It's an object so incredibly repulsive that nothing, not even light, can ever enter it. Therefore, it's constantly ejecting matter rather than consuming it. There are many theories on what white holes could mean for the universe if they exist, ranging from one suggestion that the Big Bang itself was actually a white hole event, to another idea that white holes could be the exit points for real-life wormholes bridging between universes. One of the greatest puzzles for these mind-bending structures, though, is that if matter is constantly falling out of them, then how did that matter get inside in the first place? One theory, or group of theories, rests on the idea that black and white holes aren't just opposites, they're connected. We know that it would be easy to fall into a black hole if you were to ever get too close to one, at which point you'd find yourself mercifully spaghettified as the atoms that make up your body are stretched and stretched apart toward the singularity. Nobody knows, though, what happens to the matter next, which is where white holes come in. According to some models, black and white holes could actually be the exact same object, or two stages in the life cycle of the same object, which means that the only way into a white hole is via a black hole first of all. That black hole would then lead you to an exit point, or else reform into its repulsive other and spew you out that way. Unfortunately for you, you'd have long died by the time any of this happens, if any of it happens. But hey, at least your spaghettified atoms would find their way back out into the universe to become something new. Still, simply finding yourself, or the particles that make up yourself, inside a white hole isn't quite the same thing as falling into one from the outside. Approaching the problem from the front would be no easy feat, however. In fact, it would be impossible unless you were to devise a way to travel faster than light. FTL speed is really the minimum requirement for falling into a white hole, because nothing short of that would get you past its own event horizon, i.e. past the boundary at which nothing, not even light, can enter it. In this scenario, then, you wouldn't really be falling at all. You'd be hurtling forwards at more than light speed, which means more than 299,792,458 meters per second. If you were traveling in anywhere close to the traditional sense, you could well need an infinite power source to do so. We could potentially say then that falling into a white hole would require unlimited energy. We can definitely say that it wouldn't be easy. One way around the obstacle of FTL travel would be an Alcubierre drive, one of the leading proposals for a warp drive design. While a totally hypothetical machine at the moment, an Alcubierre drive would create a bubble of space-time around a vehicle to enable superspeed. It works in theory because locally within the bubble, the speed of light never needs to be broken. Instead, space-time is bent or warped around the bubble, moving the traveler through space at an infinitely faster rate. You get from A to B, and the laws of physics remain relatively intact. Of course, right now we don't know whether an Alcubierre drive could ever be possible, but regardless, that's the level of kit you'd need for this task. Say you've managed to build yourself an Alcubierre drive, however. On the one hand, you'd be the toast of science and engineering and a pioneering inventor. On the other, you've still got a long way to go before you could safely approach a white hole. Even were space-time to be warped and distorted all around you, you'd still be racing toward an object that's firing out a constant stream of matter at a mind-boggling rate. Even in the vastness of space, there are few situations that are more dangerous than this one. The main problem is that you'd need a completely indestructible ship. Why? Well, let's scale back for a second and think about the International Space Station. It orbits the Earth at the relatively modest speed of 7,660 meters per second, And yet sometimes it needs to perform evasive maneuvers to get away from dangerous space debris like other smaller satellites or loose bits of rock. Because both the debris and the ISS are traveling so quickly, even a small item could have a devastating impact. Now let's zoom out again and back to the entrance of our white hole. Not only would you have to exceed the speed of light to get through it, but everything else, all of the rejected repelled matter heading in the opposite direction and straight towards you, would be moving incredibly fast too. Ultra-high-speed collisions then would be impossible to avoid. And unless your ship was up to the task, just one such collision with even a tiny piece of matter could destroy your vehicle and kill you. But what if you've managed to build an Alcubierre drive and design an indestructible ship? Your last major complication comes in the form of time available, because the window of opportunity with white holes could be very small. One theory on the nature of these things is that they can only survive for as long as they have matter to eject. When that matter runs out, they disappear. Considering again the speeds we're dealing with, it could then be the case that white holes are extremely short-lived, which is one reason why we're yet to find one in reality. So to even have a chance of getting into one, you'd need to be on the scene in a flash, perhaps literally, which means you'd need either to be incredibly fortunate and just so happen to be in the right place at the right time, or you'd need a supreme and instantaneous location device. Say you've worked all of that out though. You've powered your way through space at FTL speeds, avoided all of the endless stuff that your enigmatic target can throw at you, you've arrived in time not to miss anything, and you've passed the event horizon. Would your incredible physics-defying self or vehicle remain quite so effective inside the white hole itself? Well, at this point, it's truly impossible to know. If the inside of a white hole is anything like what scientists suspect the inside of a black hole to be, then it's an extreme and extremely unwelcoming place. And if these structures really did amount to one half of a wormhole, then you're in for a deluge of what's generally referred to as exotic matter, the unknown particles and atoms that scientists believe are necessary for wormholes to exist. What's almost certain is that the nature of your reality will have changed beyond all current comprehension. And while you might be safe inside an ordinarily indestructible ship, there's no telling how it would react to the otherwise totally fundamentally alien landscape outside of your window. More than likely, you'd find yourself disintegrated, unaware of what was happening to you until it had already happened. But if the theory we mentioned at the beginning of this video, that the Big Bang was a white hole event, holds true, then your floating white hole defeating atoms could yet form the basis of a brand new world. They are one of modern science's greatest unknowns. But that's what would happen if you fell into a white hole.